Hello, I am IPSITA Ghosh. I am the Assistant Professor of Swami Vivekananda Institute of Science and Technology, and today I am going to discuss on the topic of system and the properties of system. So first we have to know what is a system. A system's process input signal to produce an output signal. A system may be defined as a set of elements or functional block which are connected together and produce an output in the response to an input signal. That means the system takes a signal as an output, as an input, and the transform into another signal as an output signal. As shown in the figure, a box diagram is represented by a system. In the left side, I am indicating the input signal xt, and in the right side, I am indicating the output signal yt. The response or output of the system depends upon the transfer function of the system. That means the system has the characteristic, suppose multiplier. So suppose the system is multiplied. That means the input signal is coming to the system and then it is multiplied with the parameter which is given in the system. Suppose multiplier has the value 2. So the input is multiplied with the 2 value and it is given to the output like 2 into xt. So yt is represented as a function of xt. Now in case of system, I am giving the example of various type of filters, amplifiers, communication channels. They are all electrical system. Big systems like TV set is the interconnection of the small system like tuner, IF amplifier, video amplifier, sound amplifier, etc. There are different types of system like signals. The system also may be defined as two types. One is continuous time system, another is discrete time system. Continuous time systems may be defined as those systems in which the associated signals are also continuous. This means that input and output of continuous time systems are both continuous time signal. For example, audio video amplifiers, power supplies, etc. are continuous time system. Now, let us discuss about one simple practical example of a continuous time signal. Suppose we consider a simple RC circuit as shown in figure, where I am giving some source voltage to one capacitor, and in other words we can say that for this particular system the source voltage is the input signal and the capacitor voltage is the output signal. So this is the example of continuous time system. Next, I am discussing about discrete time system. Discrete time system may be defined as a system in which the associated signals are also discrete time signals. This means that in a discrete time system, the input and the output are both discrete time signals. For example, microprocessor, semiconductor memories, shift registers, etc. discrete time system. In that case, the signal, discrete input signal is xn and discrete output signal is yn. Next, the properties of system. First one is linearity, time invariance, causality, stability and invariability. The first I am discussing about linearity property. A system is said to be linear if it is satisfies the principle of superposition and also the principle of scaling, because in the figure the input signal is xt equal to a1 x1t plus a2 x2t. So here I am taking two signal x1t and x2t. x1t is multiplied with a scaling factor a1t and x2t is multiplied with a scaling factor a2t. Then it is added and the whole signal is acts like a input signal to the system. That means the linear system may be defined as one whose response to the sum of the weighted input is same as the sum of the weighted response, because in the output side it is seen that yt equal to a1 y1t plus a2 y2t. Okay, let us discuss it briefly. Suppose we consider one system where I am giving the input x1t and I am getting the output y1t, and in the same system next input is x2t and the output is y2t. In the next case A1 is multiplied with x1t, then we getting A1 x1t, and if this input is passes through the system and I am getting the output A1 y1t, so I am saying that system is satisfying the scaling property because the input is multiplied with a scaling factor A1 and also the output, previous output, when I am giving the input x1t and I am getting the output y1t. Now I am giving the input A1 x1t and I am getting the output A1 y1t. So the signal, input signal is multiplied with A1 and also the output signal is multiplied with A1. A1 x1t is passing through the system and I am getting the output A1 y1t. So the system is satisfying the scaling property. Similarly, I am passing x2t and getting y2t, and if I am passing a1 a2 x2t, then I am getting a2 y2t. So the system is satisfying the scaling property. In the next time, I am giving the input a1 x1t plus a2 x2t. That means the summation of these two signals. And if I am getting a1 y1t plus a2 y2t, that means the summation of the previous two output, then the system is said to be linear. So in one language, it is said that linear system may be defined as one whose response to the sum of the weighted inputs is same as the sum of the weighted response. So if the system is non-linear, then they not satisfy this property. So the system is linear if the output of scaled sum of the two input signal is the equivalent scaled sum of the output signal. And if the system is non-linear, then it not satisfy this kind of, but they will not satisfy this kind of property. Next one is time invariance property. Time invariance property. A system is time invariant if the input-output relationship does not vary with time. This means that a system is time invariant if its behavior and input-output characteristics do not change with respect to time. That means if a time delay or a time advance input signal is given to the system, then the identical time shift is shown in the output signal as shown in the figure. Here the input is xt minus t naught and the output is yt minus t naught. Suppose I am taking the input signal xt and it is passing through the system and we are getting the output yt. Now, in the same system, I am giving the input xt minus t naught. Now, what is xt minus t naught? It is a delayed signal. Why it is a delayed signal? Because here the time scale is delayed by a factor t naught. It is a right shifted signal, so it is a delayed signal. Xt minus t naught is given to the system. That means I am giving a delayed input to the system, and in the output we are getting the same output yt but is in the delayed version. Which amount delay? Same amount of delay in case of output signal also. So I am giving xt minus t naught and we are getting yt minus t naught. So the input output characteristics of the system does not change with respect to time. The same figure is coming but in the shifted version. Suppose I am giving one sine wave to the input signal and getting square wave to the output signal, and if I am giving the shifted sine wave in the system, then I am also getting the shifted square wave in the output side also. That means giving sine wave and getting square wave, and in the next case also I am giving the sine wave but in the shifted version and I am getting the same square wave but in the shifted version. So the system is time invariant if the output of delayed signal is equal to the delayed output. Then I am saying that the system is time invariant system. And if the input output characteristics of the system changes with time, then the system is known as time varying system. In generally all systems are time varying because the RC circuit will be a time invariant continuous time system if the values of resistance and the capacitance are constant with time. On the other hand, the RC will be a time variant continuous time system if the values of resistance R and the capacitance C changes with time. So it is dependent on the value of R and C. Okay. Next, the causality property. Next, the causality property. A system is said to be a causal system if the response or output does not begin before the input function is applied. That means a system is said to be a causal system if the present value of the output signal, which is depend only on present value or the past value of the input signal, not on the future value. So it is mathematically shown that yt0 equal to f of xt, where t must be less than equal to t0. That means at t0 time, this is our present time. Suppose at t0 time, it is our present time, and xt has the value which is less than t less than equal to t0, then I am getting it is a causal system. So this is our causality property, where the system satisfy this condition. In other words, we can say that causal system are where the response of the output of the causal system to an input does not depend on the future value, because here I am saying it is depend on the present or the past value. This means that all real-time systems are also a causal system, since this system cannot know the future value of the input signal when it constructs the output signal. So causal systems are physically realizable. But non-causal system is depends on the future value. It may be depends on the present value or past value, but it must be depend on the future value. Next one is stability property. The first we have to know what is BIBO, stable system. Now what is the full form of BIBO? BIBO means bounded input, bounded output. Bounded input, bounded output. So if the signal is said to be bounded, that means its magnitude is always has a finite value. Suppose a sine wave is a bounded signal, since its magnitude is always less than or equal to a peak amplitude. So any signal which satisfy this property, that means the magnitude is always has a finite value, so this is said as a bounded signal. And any signal which does not satisfy the property where the magnitude is has the infinite value or not the finite value, then the signal is called unbounded signal. So a system is called a bounded input, bounded output stable if and only if every bounded input results in a bounded output. The output of such system does not diverge or does not grow unreasonably large. So this is a bounded input, bounded output stable system. So a system is bounded input, bounded output stable system if and only if every bounded input results in a bounded output. As shown in the figure, in the input signal, here I am giving mod of xt is less than equal to mx less than infinity. Here mx is one constant value which has a finite value, and that is shown by the less than infinity. Mx less than infinity, that means mx is a finite value. And mod of xt is less than equal to mx, that means the mod of xt is in between the range of mx, that means the xt has a value from minus mx to plus mx, that means it is a bounded signal, and this is given to the input of the system, and we are getting the output yt, which is less than equal to my and less than infinity. Here also my is a constant value because it is less than infinity value, and mod of yt is less than equal to my. That means yt taking the value from minus my to plus my. So this is also a bounded signal. So I am giving input signal which is bounded, and I am also getting one bounded signal. So the system is bounded input, bounded output stable system. So this is our stability property. Next one is invertibility property. So first I have to know what is invertible system. A system is said to be invertible if the if there is a one-to-one correspondence between input and output signals. If the system is invertible, then there an inverse system obviously exists. So a system, in one language we can say a system is said to be invertible if the input of the system can be recovered from the system output. That means the cascading of an invertible system and the inverse system equivalent to the identity system. In the figure I am showing that xt is the input and passing through the system whose transfer function is h, and I am getting the output yt, and the same output yt is passing through the another system and I am getting the same input xt. I am getting the same input xt. That means I am giving the input xt, then it is passing through one system and getting the output yt. Then this yt is given to the input of the another system and I am getting the same output as the previous one input. So by cascading of these two systems, I am getting the same input. So the first one system is called the invertible system and the second one system is called the inverse system. A system is known as invertible system if it will have a inverse system. Suppose I am taking one example. I am giving one input xt to a system whose which is a multiplier and it is multiplied the input by 3. So I am giving the input xt and it is multiplied with 3 and I am getting the output 3xt. Now this 3xt is passing through another system which is the inverse of the previous one. That means it is 1/3 of the input. It gives the output as the 1/3 of the input. So I am giving the input 3xt and it is multiplied with 1/3. So I am getting the output xt. So first I am giving the input xt, then it is multiplied with a 3, that is the invertible system, and getting the output 3xt. Now this 3xt is given to the second system which is the inverse system, then it is multiplied with 1/3 and I am getting the output xt. So this is known as also identity system. The cascading of an invertible system and its inverse system is equivalent to the identity system. And the frequency response of an inverse system is basically the reciprocal of the frequency response of the original system which is invertible system. So first one is the invertible system and the second one is the inverse system. First one transfer function is h and the second one transfer function is h inverse. So these are the properties of the system. Thank you.